we're going to go on a little bit of a journey right now through a kind of fairy tale world of sorts, one very different than our own, a world in which the dreams of mathematicians actually come true, and computers can solve all problems. So you wake up, you're a programmer. You learn to code in the formal logic classes you took in undergrad, like a lot of people. You learned how to define programs by exactly specifying what a solution looks like. And since computers can operate millions of logical predicates per second, it's not really a big deal to worry about efficiency anymore. Now, your first big project in undergrad was to write a perfect virus scanner. And you did this by defining what a virus was in formal logic. And it took a few pages in your notebook, but eventually you had a definition of a virus as a self-replicating program, and then you had a program that could read an A file and tell you true or false whether or not it was a virus. Worked perfectly. Now, you did a lot of cool projects in undergrad, like solving the traveling salesman problem. You just needed to define what a graph was and what an optimal solution was, in this case, shortest delivery path that doesn't involve backtracking, and then you were set. Now, programming isn't the most lucrative job in the world, but it's one that pays enough that you can afford one of those cool new dedicated banking cables that go straight from your bank to your home. And these descendants of the old telegraph system are really the only secure communication in the world, since software can easily be broken. I mean, password system is ridiculous because it would take about 2 lines of code to select the right string to break the system no matter what. So these things are all, it's very similar to the way reverse engineering works, actually, where you can take a product, and if you can create a sufficient mathematical model of it, you can just solve for the right parameters that allow you to copy almost any physical product. And intellectual property just doesn't mean much anymore, since most programmers work on that kind of thing. Although there's something that doesn't feel right as you're drinking your morning cup of coffee. You're thinking about a couple of things you learned back in undergrad. You're thinking about the fact that programs are finite. You know, they have a finite length, and there's a finite number of keys on the keyboard. And you remember in the back of your head that that means that on some level, you can enumerate all the programs. You could take all the programs that are possible and label them 1, 2, 3, 4. And the weird thing is, you're also remembering an old proof that there's more numbers between 0 and 1 than you can count. And it goes something like, if they were countable, then you can make a giant table where the rows are numbers and the columns are the digits of the numbers. And if you can make that table, you can make a number that can't fit in the table by going along the diagonal and adding 1 to each number. And clearly that's a new number between 0 and 1, but disagrees with every entry at the table at least at 1 point. So, well, since this is a number, you've kind of proved that there's no such, that this table isn't possible. Now, can you do something similar with programs that analyze other programs, like your virus scanner? Now, if the rows are programs doing the analyzing and the columns are the source code of the programs being analyzed, then couldn't you just make a program that reads off of that diagonal again and does the opposite every time, since each cell is either true or false in the analysis? And so, because these are programs like your virus scanner. And this seems like it makes sense. It seems like this is a program you can run that does the opposite of everything in this table. Now, wait a second though. The table has to exist because there's a countable number of programs. So what's wrong here? It must mean that this isn't really a program. So, but you have it right in front of you. You can just run it right now. And the world goes black. You wake up, and you are now in the real world again, and a world in which the number of things you can write in code is infinitesimally small in comparison to things definable in logic and mathematics. This is a world where there's no such thing as a perfect virus scanner, nor can there ever be. There is no one-step password cracker, and projects like the solving the traveling salesman problem, solutions exist, but they take longer than your lifetime for a non-trivial roadmap. And this is because of the very finite nature of programs. This is baked into the universe itself by the very fact that programs are finite things that can read each other and themselves. And this may be frustrating sometimes, but you love and appreciate the fact that this makes programming interesting and it makes it a real project. And so you go to work. Thank you.